Christopher Bertels. That's the German way how I say it. You can just call me Chris. I'm from Germany. I'm a student at a university in Osnabrück, which is a town there where I'm from. I'm doing an internship at Twitter right now, and so I'm in San Francisco right now. And I'm going to talk about Fancy, which is a new dynamic, object-oriented programming language that runs on Rubinius. Basically going to show some language features, and then at the end show some like implementation details and like what Rubinius has to offer in terms of functionality for language creators and people that want to play around with that kind of stuff. If you have any questions that are like very related to the slide, just raise your hand. Otherwise, for like more general stuff, we can do that at the end. So, motivation. I've always been interested in programming languages. I did some fun toy languages, implemented them in Ruby. I actually wrote interpreters in Ruby, which was so slow. But it was fun. Ruby's very expressive, and it's fun to play around. Also, there's great tools for it, parser generators, stuff like that. But Fancy started out as a C++-based interpreter, similar to like MRI, but written in C++. And about a year ago, I and another guy from Mexico called Victor, we ported it to Rubinius within like 2 weeks or so. And the interesting thing is that the implementation before was like 14,000 or 15,000 lines of C++ for the interpreter, and then like 7,000 lines of standard library in the language itself. And then after we ported it to initial version written in Ruby, where the compiler was written in Ruby, we ended up with like around 2,000 or 3,000 lines of Ruby and 10,000 lines in the standard library, and it was faster. And that's crazy. Well, I don't know, maybe my C++ isn't that good, but I think it's mostly due to the Rubinius guys, what they've put into the VM. So yeah, what is Fancy about? It's I wanted to create a language that is easy to understand and extend within the language, that has very consistent semantics, so there's like no magic going on. And if you want to look at how something works, you just look up the method definition, and there you have it. That's well documented as well. So I looked at different language implementations, and not just Ruby, all kinds of implementations. And what I found is that there's good documentation at the API level, like standard library stuff, but not really for the implementation itself. So I kind of wanted to change that. It's supposed to be very noob-friendly. Like if you're new to the language, it should be able to get the hang of it quite fast. If not, that's my fault. And without any ambiguity. So both in terms of syntax and semantics, it should be like obvious, like when you look at the code, like what it's doing. So yeah, that are the goals. Inspirations. Biggest one probably Smalltalk and Ruby. Those two, they're the main inspiration. Then there's IO, which is a dynamic language created by Steve DeCourt. Who ever heard of IO? Okay, it's a very interesting language, and I took some stuff from that, which I'm going to talk about in a bit. And Erlang, to some extent, mostly for like, well, we'll see. But the biggest ones are Smalltalk and Ruby. So from Smalltalk, what I took there was that it's object-oriented, like Ruby, but since Ruby's a descendant of Smalltalk, it all comes back to Smalltalk in the end. It has pure message passing semantics. It's the thing with Smalltalk compared to Ruby is that Smalltalk has very little syntax, whereas Ruby has a lot of syntax for a lot of things. And I try to, Fancy leans more towards the Smalltalk approach, where you really don't want to have as much special syntax for like different edge cases, but try to come up with with a system where everything can be implemented in terms of the language itself in like some base concepts. So message passing is probably the most important one here. It's very dynamic. I'd say it's probably even more dynamic than Ruby, although you could do the things that Fancy does in Ruby as well, but it's just not by default that way, and we'll see that later. It's class-based like Ruby and Smalltalk, and it's reflective, obviously. And what I take from Ruby is there's more than one way to do it. It's file-based, whereas Smalltalk typically was like an image system where you have like a live environment and you don't really edit files. This is all file-based. It embraces Unix. The literal syntax is quite similar, and naming conventions. I really like the Ruby naming conventions, so they're the same. Oh, and it's also a script like in Ruby where a class definition is actually executable code, and you can just call methods within a class definition. This is the same thing. So I/O and Erlang a bit. The main idea here is that that Fancy provides lock-free concurrency, so you don't have to deal with locking. And the way it does that is, since it's an object-oriented programming language and everything's done with message passing, there's really no reason why not to have asynchronous message passing, and that's what you would call actors. There's also futures, which basically are values that will represent the value that will be computed in the future, and I'll show some code later. So let's look a bit at syntax and semantics of the language. So here we see, you can just look at it. Arrays pretty much the same. Tuples, Ruby itself doesn't have tuples built in, but Rubinius has them because they use them. Tuples are basically fixed size containers where you can't just append new elements to it. They're once you create it, it's fixed size. But the thing is, they're very memory efficient because they can map directly to C arrays, which are also fixed size. And Rubinius uses them internally in the VM for stuff like implementing, I think, hashes and stuff like that, lookup tables, maybe even, I don't know. But yeah, so since Rubinius has it, I thought, why not have it in the language itself? Because they can be useful. And so that's Python-style syntax for it. Hashes look a little bit different, and the reason for that is because if you look one line below, there's blocks, and blocks use curly braces. And in Ruby, you have curly braces for both hashes and blocks if you use that syntax. But that just complicates the parser, and it also, ideally, I want as less collision or multiple meanings to syntax as possible. So. Then you have blocks, as I said. The first one is without an argument, where you just print foo. The second one is a block with 2 args, and then it returns the sum. And then the last one is with the @ sign in front is a partial block, I call it. It's basically a block where you can emit the first, the argument, and it just injects it in front of that plus. So if you say, an array of 1, 2, and 3, and you say map, and you pass in this, then you get 1, 2, 3 each plus 42, so 43, 44, and so on. Classes look like that. Methods. So the thing about Fancy and Smalltalk is that it's keyword messages. So methods that take multiple arguments, you define them in a way that the arguments are basically interspersed into the method definition. That makes up for it turns out to be really good for DSL type of stuff because it almost, you'll see later, but it works very well. It can be wordy, if you look at Objective-C, I think they take it to the extreme. Fancy's way more terse than that, but yeah, but it works well. And if you look at Rails code, you're passing around option hashes always anyway, so I think it's okay. Regular expressions work the same, ranges the same, and then symbols start with a tick because we want to use colon within symbol names to refer to method names and stuff like that. Numbers. Lisp, someone? Okay. Yeah, Lisp does it like that too. Anyway. Strings. Oh yeah, and we have multi-line strings. So if you do triple quote, you can have multi-line strings, and we use that for doc strings, which are Python-style doc strings, and I'll show them later as well. So class and method definitions. This is a simple class. And the first line there, read write slots, basically defines getter and setter methods. It's similar to attr accessor in Ruby. And I passed it a tuple. I could have passed an array. I could have passed actually anything that implements the enumerable interface, basically. And then the next line is the constructor method. By default, like in Ruby, constructors start with initialize, but since we have keyword arguments, it'll detect that this is a constructor method, and it'll create a class level factory method that is called new::h::city:. And then what we do there is this at name and at age and at city actually means just auto-assign it to that instance variable. Like in Ruby, you would have to now write at name equals name, at age equals age. There's really no reason why you should be doing that, because that's very common, right? So yeah, you just write like that, and it knows what to do. And then when there's no body, you can just skip the curly braces. Looks nicer, I guess. Yeah.
I don't know typo, but on the initialize line, how would you, is at name just automatically assumed to be the first variable, or do you need a name colon correct?
Oh, when you create a new object, basically? Like, what was the question? Sorry.
Oh, I just see that your rewrite slots have a name.
Yeah.
On your initialize line, you have the Smalltalk, like way of age colon at age, city colon
Yeah.
at city. I don't see the same thing for at name.
Oh, yeah, because it's a constructor. So okay. So a method that starts with initialize is automatically called when you're creating a new object.
Right.
And the way when you create a new object, it works like this. You say person new colon, and then you put in the first argument. So when you create objects and you call a constructor, the first argument doesn't have a special keyword, but the rest does have. So it would always be new colon, whatever class you do. But it's not really a problem, because in Ruby you don't have anything named, so it's not that bad.
I guess the question he's asking is, how is it inferred that it maps to the name slot?
Oh, because I say at name. That's the name of the instance variable. Like, or does that make sense?
So you're saying rewrite slots name tells your system that there's going to be an instance variable called that name.
Yeah, exactly. Yeah. So this is just like Ruby. Like in Ruby, you can just refer to an instance variable whenever, right? And you do add or accessor, and you pass in like the symbols of where you want getter and setter methods for. And so this is the same thing basically.
It's roughly like in the block argument in Ruby, you can say at name equals.
Yeah.
Assign to it when it gets past the block. So it's kind of like that, right?
I guess I'm not sure.
If you don't need the key on at name, then why do you need it for at age or at city?
Yeah.
The first argument is
Oh, so I think you're confusing the method name and the arguments to it. So whatever ends with a colon is actually part of the method. So that method is called initialize colon age colon and city colon. That's the name of the method. And then the arguments you put in between. So yeah, like in Ruby, you just call initialize and then you just pass 3 arguments. But the syntax works in a way that if you have multiple arguments, the method name basically changes. Which is the interesting thing about that is that you can't have like arity errors because the syntax doesn't allow it. You know? And that's kind of interesting for dynamic languages. Like it prevents not a lot of bugs, but like it does help sometimes.
Okay.
Yep.
So I like how this is like a combination of Objective-C and CopyScript, because I think CopyScript is the same thing.
Yeah.
But I just want to make sure, any method that starts with the word initialize is constructor.
Yeah. So basically, what that means at the compile time, it creates a new colon that starts with new. Basically, so you basically just substitute initialize with new, and then that's a class method, like in Ruby, basically. Yeah.
Is it a thing that start with initialize or initialize colon?
Doesn't matter. Well, initialize colon will create a new colon method. Initialize just like that. If you don't need any arguments, it will create. Well, by default, there's a new method and class is defined. So yeah. All right. At the bottom, so you might notice like sometimes the syntax highlighting isn't that nice. I have to work on that basically, but yeah, we have the same. It has the same thing like in Ruby where you can like insert strings into or values into strings and stuff like that. Yes.
Why did you decide to syntax as a constitution rather than method on class?
So you can do that too. You can do like object, subclass, person. I don't know. There's, yeah, I don't know. I like it like that, basically. Just like, for like common things, I think having syntax makes sense. Although I can understand your argument, but in the end, like in terms of like semantics, it's exactly the same thing. There's no difference really. So, because like this is still executable code, right? Like, it doesn't matter. Okay. Flow control. So here's an example of if then else. Basically, what what you'll see here, this is actually like, there's a method called if then else. It takes 3 arguments. First argument is some value.
That's really awesome. We're not being sarcastic.
Sorry, what?
That's really awesome. We're not being sarcastic.
Okay. Anyway, and then 2 blocks. So the thing in Fancy is blocks are first class. You don't have, there's no special syntax for it. Anything that's within like curly braces is a block object, and they're just normal parameters. So yeah, that's actually how all the control flow looping stuff works. Yeah, while do. There's this stuff, like Ruby, you can put the if at the end. It's the same thing here, basically.
Rubinius must love this tree.
Why?
Because it's all methods. They can be
Oh yeah, so I'll show some bytecode later. Typically, fancy code, the way when it compiles the bytecode is just send everywhere. Everything's a send. All right. So actors, right? Yeah. So it's a message passing, and actors basically are concurrent objects. They're asynchronous. You send a message, and you don't get a value back. Or in terms of futures, you do get a value back, but that points to the value that will be computed. So there's syntax for that, because it's very useful. And so the way you send an asynchronous message is you just put 2 @ signs between the receiver and the method name, and that's it. And it returns nil immediately, but what it does, it sends it to the object's actor. So in Fancy, every object can be an actor. And the way it works is basically the first time you send an asynchronous message to that object, it spawns an actor, which right now runs in a thread. But there's different ways to implement that. And it has a mailbox and a actor loop, basically, similar to like Erlang or other languages, where basically you don't have to think about synchronization, because the mailbox ensures that messages get processed first in, first out. So if you send multiple messages, it'll only process one at a time. And so within the actor, you can do mutation, because you're guaranteed that nothing is happening concurrently within the actor. Anyway. And then future sends are similar, but you get a value back, and you just use 1 @ sign, and the value is a future send object, which if you call value on it, you get the value back. And if the computation hasn't finished yet, it'll block the thread that tries to call it. I/O has transparent futures, and I have a branch for that. And I might actually make that the default, but for now, you have to call value explicitly. If you use transparent futures, the benefit of that is it's totally composable with any other API, because they don't even have to know it's a future. So anytime it expects a normal value, you could pass a future send into it, and it would implicitly call value if the value hasn't been computed yet. But yeah, I'll do that maybe sometime. So here's a short example. This is like a typical like Erlang style. Yeah. Yeah, so you can also register callbacks. You can do that, but yeah, so it's possible. Small actor example, a ring. If you know Erlang, there's like this benchmark, like there's an example, and a simple thing. It's basically a list of nodes that send, like a list of actors that send a message around, and then you basically look at how long it takes. Erlang is really fast because they have lightweight processes. I wish Rubinius had something like that, but for now I have to use threads. And the current implementation, the way it works is it spawns a thread per actor. So that works fine until you hit like a certain amount of actors, because you don't want like 10,000 of threads running on your system. So there's another way to do that with thread pool and stuff like that. And I have an implementation of that, but the current one just uses the Rubinius actor API, which spawns a thread per actor. So we have a node class, and it takes 2 arguments. It takes a next node and a ring object, which is like the manager or whatever. And then it has a count method that takes a current count, and if it's done, like if there's no next object because it's nil, you just say I'm done, and you tell the ring you're finished. Otherwise, you print 1 dot, and then you send to your next node the incremented count. The ring looks like that. You basically specify how many nodes you want. You create basically a linked list of nodes, and then you start it, and you finish. And then that's the code at the bottom that actually starts it. So you say ring is a new ring with 4,000 actors. You say start, and you give it the current thread, so it knows like which because you don't want to like finish right away, because if I wouldn't have the last line, the thread stop there, the script would just finish, because it starts threads, but the main execution thread is just going to finish. So I give it the current thread, and then I stop, and then it will run, like resume me in the finish method on the left. I'm going to show this real quick. So, all right, let's see. So I run this, and you will see it's not like Erlang super fast, but again, this is 4,000 threads, and I do kill them after they've been spawned. But for this example, probably a thread pool would be much more better. But yeah, anyway. So yeah, there you go. Whoop. So it definitely works. Performance is definitely something that can be worked on. But usually, if you have like a system where you want to use actors, you shouldn't be you can have them, but it probably makes more sense to have like certain roles of your application be within an actor, and then you won't have like thousands of them. I don't know. Okay, so back. Yeah. Yeah, the first implementation was using fibers. Yeah, definitely. No, yeah. I have a fiber implementation. I have a thread pool implementation. The current one is using the actor library. And I'm still playing around, but like if anybody else wants see how that works, it's definitely possible. Yeah, it's basically just work you have to do. That's it. But I think I still have the code around somewhere. Yeah. Oh, yeah, sorry. So there's two special operators in Fancy, the $sign and the dot operator. $sign is like it's taken from Haskell, basically. It means everything to the right of it is one expression and passed to whatever's on the left. So in this case, thread current is on the right side, and it's one expression and passed to the start method. The reason it works like that is Fancy syntax works in a way that everything is left to right only. Like you always go from left to right, and yeah.
You mean you don't have 3 levels of precedence for your keyword args?
No, not right now. I could. So the reason why it's actually interesting why I don't have that. Smalltalk has it, and most keyword messaging-based systems do have it. But if you use $ and dot, you actually save a character because you don't have to do parens. And for keyword, if you keyword args, yeah, you sometimes have to use parentheses. But I don't know. I might fix that. I haven't seen many cases where it's super annoying or very annoying or annoying at all. Usually, if you have, well, my take on it is if you have methods that take more than 2 arguments or 3, it's too much anyway, because then you should probably like encapsulate that in a new abstraction. And so you usually end up with like at most 3 arguments to a method, maybe sometimes more, but yeah, usually that's a bad sign. So I'd say refactor that.
Do you have, my biggest complaints with Smalltalk syntax is their use of keywords to essentially do what we do with splice, and just keep repeating out the method.
Oh yeah, no, I don't do that. I just pass an array. Done. Yeah. Sorry? No, it's all one. Yeah. Yeah. Okay, so yeah, Fancy runs on Rubinius, and it would be a shame if we wouldn't integrate with Ruby, right? There's so much code out there, cool stuff, libraries, and just like being able to use a standard library, I don't want to re-implement all that stuff. So Fancy has, I think, pretty good integration with Ruby. Not just at the bytecode level, obviously that's no problem, but also like syntactically and like how the semantics work. So the idea is, if you have like, so there's a lot of things that in Fancy are, how do you say it? Like the standard classes, like standard library stuff. There's cases where we have a fancy version of a method, and it has the same name basically as a Ruby method. And the way the method names work in Fancy is you either have no arguments, so there's no colon, or you have arguments and there is a colon. And the colon version is not a problem because Ruby doesn't have colons in method names, so there's no conflict basically. For no argument methods, they can conflict just by the name. They could conflict with Ruby methods that have the same name but might take multiple arguments or stuff like that. And so we prefix those basically with a colon. So no argument methods start with a colon. You don't have to deal with that. The language just does it at compile time. If you want, there's a Ruby gem for Fancy, so you can actually use Fancy within Ruby. There's a little helper syntax that, not syntax, like a little DSL thing that abstracts that away too. But yeah. So there's special syntax for calling out to Ruby, and here's like an example where we basically reuse what's there. So at the top we define like aliases because the way we don't want to like conflict with that. We might have different semantics for like say some operation, like some method. So what we do here is we, in this case, we just alias them, but we have to do that explicitly. Otherwise, it wouldn't know what to call. And then in the constructor method, you can see I'm just calling out to Ruby, and the way that works is you always use explicit parens, and that's how basically. So you basically just skip the dot. That's it. Yeah.
Are you reopening Ruby's array class here, or is this?
Yeah, because I want to use a lot of their functionality. But yeah, a lot of the standard library reuses Ruby classes. There's a bunch of stuff that isn't in Ruby, so that's basically homegrown. And it's usually a mix. So I actually separated the code. Like if you look in the standard library, there's lib, and then there's lib/rbx, and that's all the extension stuff like that deals with Ruby stuff. And then there's just lib. And then everything's pure Fancy. Doesn't even know necessarily there's Ruby behind it. Yeah. And that would be interesting if you wanted to port it ever, like port it to a different system. You could just use the lib stuff and do the other thing. But I'm not really intending to do anything, but maybe someone would. So yeah, we can even pass like blocks. And this is actually not the real definition of reject. I changed it a while ago, but just wanted to show the ampersand thing that works as well. We even can pass like splat arcs and stuff like that. So, so the idea with Fancy is that Ruby's pretty similar too, but the idea is that everything should be first class, and Rubinius is a great platform for that because it's implemented almost entirely, well, not entirely, but at the language level, and the libraries and stuff like that. Everything's implemented in Ruby. So, so Fancy tries to have as much first class as well. As I've mentioned, blocks are first class. So, and actually, that's really interesting. You can do that in Ruby, of course. You can pass lambdas around or like procs or stuff, but having it like just natural in the language makes a lot of sense. So you can do things like each in between. That's a method. It takes 2 blocks, and it calls the each for every element in the list, and calls the in between block in between each of those. So you can do like this is the array inspect method basically, and it creates a string. Yeah, that's what it does. Another thing that's first class in Ruby and Fancy is documentation. So Fancy doesn't have a documentation parser like RDoc. We have a documentation system called fdoc, but it's the way it works is it's not actually parsing anything. It's loading up Fancy and then asking every object in the system, give me your documentation. And then you don't have to parse anything. And since I'm lazy, and I like documentation, but I don't want to write another parser because I hate parsers, that works out very good. So this is like a sample, like standard documentation string. And we have like this convention that if you prefix something with an @ sign, it gets like specially highlighted. And in terms of the way we do it is like at the top you define the argument names, what the role is, and the return value. And so if you see like @block refers to the block argument, and then @block actually creates a link so you can click around between classes. That links to the block class when you look it up in the browser. So we have an HTML version of the documentation, and it's like interactive. And then there's like indented is some sample code that explains what the method does, and that also gets specially formatted because it's indented. We use rdiscount, the gem, to generate HTML. And then that's the implementation. So that's actually pretty common for fancy code. You have like a huge chunk of like just doc strings and then like 2 lines of code. And it's kind of cool. Yeah. So here's a video showing me the documentation system. And the way it works is we start up when we call fdoc. It's a little command line tool. And it loads up all of fancy and it registers a little hook. And I can show that in a sec, but just watch this for a sec. So we have like, instance methods and they're like clickable and stuff. And I think this uses jQuery. And then here you see the documentation like formatted and stuff. And that's a cool thing. If you click on that, it was a little AutoCAD. You jump to the definition on GitHub with highlighting, which I think is cool. Yeah. Oh yeah, and then you can click on block there, and it jumps to the block definition. And so, what did I want to say? Oh yeah, so the way it works is we basically, if you look at the general bytecode, these doc strings, they actually compile to message sends. So when you load a class file, what it does is it executes it, and then within that, after that class definition, or after every method definition, it calls a documentation colon method, I think it's called. And that registers that documentation with that object. And for fdoc, what we do is before we actually load all of fancy, we just insert a little hook there and say, not only just define the documentation for the object, but also like register it somewhere else so we can like generate the documentation for it later. And then at the end, we just emit a huge chunk of JSON, and we use jQuery and some stuff so it's all dynamic, basically. So this is the definition of fdoc, and it uses fdoc to document itself, which is kind of cool. So you can look at the documentation for fdoc within fdoc. It's not really interesting, but yeah. So first class also, yeah.
I just have a brief question about that previous slide. There's no colon between fancy and fdoc. What's that?
Oh, that's a nested class.
Okay.
Yeah. So nested class names, you refer to them by space, just space. And this just means it has been defined before, I think. If you wanted to define it on the spot, a new nested class, you'd say class foo, and then within that class bar, and then like that. All right. So methods first class. As you might know, Rubinius has compiled method objects, so methods are already objects in Rubinius, and I think in Ruby you can refer to them too. But yeah, so if you define the way the syntax works, and I think this is the same for Rubinius, for Ruby on Rubinius, is a method definition is actually, it returns an object. So you can refer to that, and you could, like, just inline with the syntax, you can do, like, inspect. And if you do that in the interpreter, it'll, give you a compiled method object. Why is that interesting? So Ruby supports this too, but I think it's a very important concept. The same thing for, like, first-class objects, classes, I mean, is that you could do things like, have a test, like have a list of tests associated with every method. So Fancy has the testing library, which I will show in a second. I don't have it, like, it's currently commented out because it didn't work very well, but ideally, if you have testing and you want to make sure you have good test coverage, the way you could like do that is, as a first step, to basically look at every method in the system and ask it for its tests, and if it doesn't have any tests, you should probably write one. So and again, you save a lot of special effort for that. Wait a second. Oh, come on. Okay. So speaking of testing, there's fancypack, which is basically an RSpec-like testing library, and it's pretty lightweight. It's like 430 lines of code, but it all covers everything I need for now. All the standard library is tested that way, and I wrote this like when I was still working on the C++ implementation. So this helped a lot from when migrating to Rubinius, because I never tested the C++ implementation itself, just the standard library and the runtime behavior. And by the time all those tests passed on Rubinius, well, it worked. So that was kind of cool. Yeah, so that's very nice. And here's like an example how it works. So you say fancypack describe array with, then you pass a block, and in there you can say it contains 3 number values after adding them with the shift or whatever insert operator when, and then when array is 1, 2, 3, and the array size is 3. And what you see here is, first of all, we say explicitly what class we're using, and that's the same for our spec. But then we also define the method name. And that's what I was referring to earlier. You can now associate this test case with the method of that class. And that's how you could say, have a simple way of figuring out test coverage in a way. So that works. Here's you can also test exceptions, like expected exceptions. So you have a block and you raise an exception, then you say that block raises a standard error with E, where E's message is the message we defined above, and that'll pass if it actually raises it. And so so here's like a fspec run, and it prints dots like rspec and stuff like that. So some other fun stuff that Fancy has dynamic scoping. If anybody who has done Lisp before, or like Clojure, whatever, cool. So dynamic scoping is pretty popular in like Lisp type style languages. It basically means that you can refer to like variables. They have their binding is dynamic. So say you have. This is actually how we do input-output in Fancy. So you have like star standard out star and standard in and stuff like that, and you can just rebind it within a block. And any method, any execution within that block, the standard out value will be whatever you set it. So here we have let standard out be f, and f is just a file in that block. And now I can call any method. Like I'm calling printline, which by default prints on star standard out star. Yeah, it's kind of like globals, but not really, because they're thread safe, basically. So they're implemented using thread locals, and when you spawn a new thread and you have any of these defined, they basically get copied over. So you're never in. It's not like globals where multiple threads running could like interfere with each other or something. Yeah.
Can you do that for constants and method definitions too?
Not yet. Maybe soon. That would be cool, yeah. Okay. Other stuff, we have, Fancy has a built-in package system or whatever. You can define dependencies, and they're in like fancypack files. This is actually an actual definition, which Konstantin wrote. He's sitting over there. It's a thin wrapper for Sinatra. So you can write Sinatra applications using Fancy, and that works. I've built a simple wiki with it, and you can do all the stuff you can do with Ruby, basically. And then you can define explicit normal Fancy dependencies and Ruby dependencies and version as well, if you want to. And then you say, like on the terminal, you'd say like Fancy install rkh/sinatra.fy. And what that does is, I just use GitHub by default. So if you don't specify a version, it just takes master. You can specify a version, then it looks for a tag with that name. And it just works with GitHub and downloads it, basically. And then you can, within your code, you can say require Sinatra, or yeah, and then it works, basically. So yeah, there's support for Emacs. This is all the code you saw was like the Emacs mode, and it's not very good. It's not like doesn't have like a lot of like auto completion stuff, and like live support or whatever. But that's mostly because I'm not very good in Emacs Lisp. There's a text-mate bundle that works, has syntax highlighting in some snippets. Vim, I don't use Vim. Brian, where's Brian? I think you should write one, because you use Vim. Anyway, yeah, other things like, this is just like for language, but like Rubinius has a lot of cool tools as well. There's like the debugger. You get like really nice, colorful backtraces, which is cool. If you've ever used Rubinius, you might have seen that. And this is something I wanted to show. There's a -cv option, so fancy -c in a file just compiles it explicitly. Usually you don't have to do that because it does it like at runtime. Like if you require a file, it'll auto-compile it if it hasn't been compiled yet. But you can do it manually, and you can also do like add the v verbose basically, and you can actually look at the bytecode, which is really cool. And if you've never looked at that, who uses Rubinius, by the way? All right, so All right, for the rest, this is cool. Wait. Oh, yeah. Actually, I'm going to show it now. I think I'm. So if you look at the actor example, that. So here you see like a bunch of stuff, but interesting. Let me see, where is it? So we have like this is like the ring definition of the class, and in here we do a bunch of stuff basically. And you can the interesting thing is here you can actually like see like the names and like local variables. They show up like for example. Let's see. Here, yeah. So there's basically a comment saying this is the ring local variable which we had, if you might remember. But that the actual like value for it that gets passed in the bytecode is 0 because that is an index into the locals dictionary or array, tuple, whatever. Yes, and the thing is, I didn't have to do anything for this because Rubinius has it, and I can just reuse it, and it works fine, and it's really helpful. Same thing for debugging and what else? Oh, backtraces, yeah, they're useful. If you've ever implemented a language and that is self-hosting, so implemented in itself, there's some really interesting bugs or crashes you can get just by changing like one line somewhere, and then suddenly the whole system doesn't work because apparently either the order in which you load stuff isn't correct, or this method is used somewhere at bootstrapping time, and it just breaks everything. And so having good backtraces is really important. Yeah, which is really cool. Okay, I'm gonna go back. Anyway, and you can use this just from Ruby as well. You just do rbx compile -b, and then do that. You can also look at the generated intermediate representation from the JIT. So Rubinius has a just-in-time compiler. It uses LVM, which is basically an API to create machine code. And there's an intermediate representation which you can look at. And you can, I think, even look at the generated machine code for methods at runtime. So why Rubinius? Well, Rubinius loves Ruby, but in fact, Rubinius actually loves dynamic languages because the way the system works. When I initially came to Rubinius, I realized that sure it's made for Ruby, but there's so many things that could have been different, like specialized for Ruby, but that are actually pretty broad and applicable to not just Ruby. So the fact that blocks are first-class objects within Rubinius, they're not first-class in Ruby. You have proc objects, and maybe that was the main reason to do it, but Rubinius doesn't care. And stuff like method names can have colons. A lot of things which I found were really cool and made it a lot easier for me to implement a new language on it. It's very hackable. Usually what I do is if I want to implement something new and I don't know how to approach it because I'm not sure how the semantics are in the VM or whatever, or in the standard library or the compiler that Rubinius has, I just look up the source and dig into it. And since it's so much Ruby code, most of the times I don't even have to look at the VM level. I can just look at the parts where it's actually exposed into the Ruby layer of Rubinius, which is really cool. So it's understandable. It's very transparent to me. And culturally, it's a very good fit. A lot of the main design decisions for Rubinius have been inspired to a large deal by Smalltalk VMs and Self, which are old dynamic languages. And since Fancy is like kind of like a Smalltalk dialect, if you will, that just made a lot of sense to use Rubinius. Okay, gotta hurry up. So there's the compiler, and Rubinius has a bytecode compiler written in Ruby, and I basically just subclass it for my bytecode compiler, and basically subclass the parts that have to be different, and reuse the parts that are fine, that are the same or similar enough. The parser is still the old Bison parser, which is a C-based parser generator, and I use it as a C extension. The reason for that is mostly because, as I said before, I hate parsers, and it's the least interesting thing to me, really. And I was lazy, and since I had C++ implementation, I used it there, and I can just reuse it. But there's there's a KPEG-based parser, which is a Ruby-based parser generator written by Evan Phoenix, who also created Rubinius, which is pretty cool. I just haven't had much time to finish that, but it's there. And what's one thing that is interesting or notable, whatever, is that most of the syntax you saw is really just compiles to message sends. So stuff like tuples, for example, are actually message sends, and that's mostly for some obscure reason, but it doesn't really matter. There's pattern matching, which I'm going to show in a bit, and stuff like that, and it's all message sends. So this is like the grammar for like identifiers, an example. And as you can see, this is the API I use for Ruby, and I use well, you can't really see it here, but I call the AST:identifier method, and that works fine. And so that's like the definition of it. In there, just create an AST identifier, and then those are like different identifier classes. And you can see there's a bytecode method, and it reuses the Rubinius classes when it makes sense. Okay, that was what skip that. So some stuff that you can do with Fancy. I think it works well for DSLs. There's some stuff I've been working on with that. There's a Parser Combinator library, which I'm going to show in a bit. Storm, which is a new system released at Twitter, I think last week, and it's basically a distributed fault-tolerant computation system that's horizontally scalable and guarantees message throughput. And it has a fancy layer. Like I wrote a little thing that you can actually write parts of like distributed jobs in Fancy. And then pattern matching, which I'm going to talk about a bit. So I wrote this Parser Combinator thing, which basically allows you to, in terms of like, it allows you to write like parsers, but it's not a generator in the sense that you have like a grammar and then you compile that to something. It's just the normal objects in the language. And the way it works, it uses operator overloading. So even stuff like and what in Ruby aren't methods, they're all methods in Fancy. And then we use blocks to do stuff with them. And yeah, like here, for example, we refer to the underscore just means don't ignore the first one, and the second one is greeted, and that refers to the first matched thing within the parentheses. And the first argument to that block is just the whole thing that you parse. And then you can see how it works. This is, I mean, you could use this to like write an actual parser for a language. I haven't done this, just playing around basically, but it kind of shows like what you can do. Like and, for example, is a method, and it creates a new combinator basically that only succeeds if the first and the second one parse, and you can come up with all kinds of schemes. All right, skip. So there's a Storm. This is like how the code would look if you wanted to do stuff. I'm just going to skip this because we don't really have time. Pattern matching, going to skip that as well. If you have questions, or I'm going to put the slides up so you can look at that. There's a lot of stuff. We use Travis for Travis CI for testing and CI and stuff. There's mixins I didn't talk about, default arguments, local returns, C extension stuff. FYI is like RI, it's like, give me some help on the command line. iFancy is the interpreter, and exception handling I didn't show. So basically what this talk should have showed is that Rubinius is a really great platform to experiment with, I think, mostly dynamic languages, but I think, you could really implement anything. It doesn't really matter. But I think it suits very well, like dynamic, probably also object-oriented, but I'm sure you could like go around that as well because they have a little hook where you can define your own lookup semantics. And the thing is that having a system that is so approachable and like makes it so easy to target it, gives you a lot of tools and capabilities, allows innovations and interesting new ideas to flourish within the Ruby ecosystem. And I think that's really great because it doesn't mean, like, I don't know if anybody's going to ever use Fancy, but maybe some of those ideas might make it into Ruby. And because people can explore and like just branch off of Rubinius and try something out. And if the other implementations think, or people think that's a good idea, people can just incorporate it. Maybe not, maybe yeah. And composability and simplicity in the language. So I think that's a good thing. There's some things I wished Ruby had different, but Ruby is popular, Fancy isn't. So I guess just, maybe people don't agree with me, but yeah, I think it's still interesting. So basically, yeah, explore, fail. I failed a couple times, and then you just retry, and in the end, we'll just win, hopefully. Some cool stuff. Atomy, it's another language on Rubinius. It's not very different, but kind of different than Fancy. It uses macros, similar to like list cell macros, and does a lot of stuff at compile time, like transformations and stuff, which is kind of cool. Whereas Fancy mostly it's purely like runtime semantics. There's a really cool video on YouTube, and I have a link down there, and you can get the slides later. It's a really cool video, and it explains like implementing your own small virtual machine for like dynamic languages. I thought it was really cool. You might want to check that out. And then there's also this book called Create Your Own Freaking Awesome Programming Language. It's a very, very simple introduction to programming language design and writing a parser and stuff like that. So that's also cool. You should check that out. Whew. Okay, I'm done. Thanks.